Folks, hello and welcome to week 4. We've got 2 weeks to go, and I know that we're going to finish this up on a strong note. As we take a look at week 4, we're right back at where we started to some degree when we finished up week 5 of Math 221, and that's dealing again with second degree polynomials. And if I saw you in Math 221, I'm sure I told you in your last discussion post to not forget how to factor a second degree polynomial, because you would see them again. And here we are again where we're now solving a second degree polynomials using a couple of different approaches. Actually, what you see here in this discussion post, you're going to solve second degree equations in a couple ways. One using factoring and the other using the quadratic formula. What you see here in this middle column, where you are solving a second degree equation by factoring, this does resemble some work we did in week 1, where we looked at the domains of rational expressions. So this will be familiar to some degree. What may or may not be familiar to some of you, if you remember from high school, or if you've had an algebra course prior to coming to us, you certainly have seen this idea of the quadratic formula. And over here, in this little PowerPoint window, I have shown you the quadratic formula, and I want to point out a couple things. First of all, I have said here that x equals, and what that would mean is if I have an equation where the variable is x, then we would say x is equal to this monstrosity here on the right. If we had a second degree equation in a different variable, let's say it was z, then this equation would start off as z. So it's not always going to be x that we use as our variable here on the left-hand side, but since I think you'll find most equations you're going to deal with in your textbook deal with x as the variables, then we will certainly go ahead and use it here as well. Before I talk about this, as a quick reminder, remember, don't forget to view the example we have here for you. It's very good in terms of showing how to incorporate the keywords, and again, it'll give you it's a little refresher here on how to solve a second degree equation by factoring, and then also how to use the quadratic formula. A couple things that I do want to mention about the quadratic formula. As it's shown here, this equation comes from the idea of taking a standard quadratic equation, ax squared plus bx plus c, and solving it by completing the square. And when you do that, this is what you get. You get this. I call this kind of this monstrosity here on the right-hand side. And what this says is that for any second degree equation, it can be solved by factoring. And when you get numerical values out of here, there are two numerical values, as you see from your reading, based on this idea of in the numerator here, you actually end up with 2 values because of the plus minus. And these are actually the solutions or the roots to your second degree equation. Just a couple things that I want to note about this, and helpful hints as you start doing your work here. I always point out the fact here that when you're looking at the b term or the coefficient here, or the value of b in the second degree equation, let me go over here and kind of show you here in kind of in general terms. So when I say ax squared plus bx plus c, what I'm talking about, if you look at assignment number 3, this 6 would be considered a, so a x squared plus b. So in this case, b is the coefficient of the linear term, or just the x term, and then c is the constant. So when we talk about this value of b here that starts off the right-hand side, notice that it's minus b. And I always like to make the point that this negative sign belongs to the quadratic formula. It is not, for instance, if you're trying to solve problem number, or if you were assigned number 8 here, if you were trying to solve this particular quadratic equation using the quadratic formula, you would still be substituting minus 2, because this negative sign here is not this negative sign here. This, again, I always say that this negative sign belongs to the equation. So the substitution for b here, if you were trying to solve number 8, would be minus 2, or ultimately it becomes plus 2. And then I think this is pretty straightforward. Again, I just caution you here to be very careful of this negative sign. This negative sign belongs to the quadratic formula. And so if your A or C value or both happen to be negative, make sure you substitute them as negative values. And again, just kind of be careful when you're substituting your values. I think if you are able to correctly identify your values of A, B, and C, then using this formula is not a big deal. Again, just being very careful or very cognizant of the negative B here. One thing I do want to point out, if you, let's say that you end up such that your radicand here, or what we term to be the discriminant, if your discriminant ends up being it being 0. We won't get into the negative here, but we do want to talk about what happens if this is 0. So the square root of 0 is 0, and then everybody would say, well, I have minus b plus or minus 0. There are still two solutions to this quadratic equation. It just so happens that you have what is called a repeating root, because obviously adding or subtracting 0 does not change the value of the numerator. But sometimes students say, well, I only have one solution. Plus 0 and minus 0 technically are considered to be two solutions, and every quadratic or every second degree equation has two solutions, whether they are real solutions or they are complex solutions. So again, I think when you go down through this first problem here where you're solving using factoring, that should be very straightforward, assuming you remembered how to factor, and I know you all have. And then again, using the quadratic formula, I think you'll find it's very easy. What I would actually challenge you to do is, obviously you have a factoring problem here to be solved using the quadratic formula, but once you go through and solve this by factoring, I would challenge you to also solve this using the quadratic formula and prove to yourself that you're going to get the same solutions either way. And I think that's always a good drill, and then you can go on and use the quadratic formula again. So I think, again, straightforward, this quadratic formula, again, very easy to use as long as you can correctly identify your values of A, B, and C. And again, it just simply comes from looking at the equation that you're given, and I think it's pretty straightforward. One final note that I want to make here. Let's say that I was given x squared plus 9x equals minus 20, and a lot of students would say, well, my C value here is negative 20. You never ever want to either try solving a quadratic equation by factoring or using the quadratic formula unless you have your equation set up in standard form. And what that means is all of the terms are on the left-hand side or the right-hand side. It doesn't matter, but it is always set equal to 0. So that is what we would consider to be standard form. So make sure before you start solving or using the quadratic formula that you have your equation set up in standard form and set equal to 0. So I hope this is helpful. Again, 2 weeks to go. I think we're going to finish this up very strong. If you have any questions or if you need any help with anything, let me know, and good luck on this post, and I look forward to seeing them on the board. Thanks.